welcome everybody to AP Physics. I would like to answer any questions that you have. Just please stop me. Okay, so we're talking about force of gravity. We're talking about torque, but we need to talk about a couple other things first. Some definitions. So the first thing is axis of rotation. Okay, and if you look on your notes, that's what it says. You might want to change it so you can read it. But axis of rotation. So if you have, so we're talking about things that are moving in circles. So we're talking about circular motion here. I probably should have had that up on top as a header. Circular motion. Okay, so the axis of rotation is perpendicular to the rotation. So what would you think the axis of the rotation would be? Okay, so here's a circular motion, and it says the axis is perpendicular to the rotation. So at this point, the rotation is in this direction, right? At this point, the rotation is in that direction. What do you think the axis of rotation is going to be? It's going to be basically a radius. Okay, does that make sense? Okay. Okay, here's another definition we need to know. It's tangential or tangential, but it's the word tangent, right? And then the IAL for the adjective part of it, speed. And I also sometimes will say tangential velocity too, but why would it be wrong to say velocity versus speed? Okay, thank you, Tyler. Because, you know, at every instant, this is going to change direction, right? So, by definition, the velocity would be continuing to change, right? But when I say tangential speed or tangential velocity, it's at a specific point in time. So, like, if this is our path here, at one point in time, it would be, in what direction would the velocity be right at this point in time? What would you say, people? Well, it's at a tangent to the path. So yeah, if it would have been to the side, it would have been straight up. Okay, does that make sense? So as you can see, this one here, at this moment in time, it's at a tangent. Okay, so due to Newton's first law, the law of inertia, you know, if I broke the string that was holding this, and you know, a second later it was just two pieces of string, what would happen to that ball? So in the AP Physics test, the question would be like this. You have a ball following a path, and then the rope snaps at that point. Okay, so you know, which direction, what's the path of the ball? The first one will be A, like that. It'll be, you know, B, like that. C, like that. Or D, like that. And your answer is, so good, everybody chose the right answer. This is the correct answer, because at that moment when it breaks, it is going to continue the way that it is. And the velocity is described as a straight line always at any individual point in time, right? Okay, so here's a question then. If you are in a car and this is an old car, so it's got just a bench for a seat. Do you know what I'm talking about? Anybody? And let's just say that, well, let's say it's a big car, because all those old cars are really big. Okay. Here's you driving the car, and here's your dates. And of course, the seat is covered with vinyl, so there's no dust in it, right? You don't get dust in it. That's what they do back then, right? You know what I'm talking about? Okay, so the thing is, you want to get more cozy with the girl, but you have no, like, you can't say anything because you're just like a loss for words. What do you do?
Yeah, you take the right turn.
Okay, so everybody, you take a right turn and you don't like slow down too much, right? Okay. So why does that work? See, before they studied this, they used to say that there was centrifugal. So the centrifugal is what they called this force that moved things towards the outside of a circular path. But now they realize that there is no force that does that. So if you see centrifugal, or if someone uses that, then you will know that they haven't taken a modern physics class. And so there's no centrifugal force. So what happens though, as you turn, this person right here, what's their velocity? The tangential velocity at this point is in this direction, right? So due to Newton's law of inertia, that body is going to want to maintain in that direction, right? So what happens so as the car is now in this situation, and the seats are really slippery, then the girl ends up sliding across the seats. But really, it might be better saying that the seats are sliding underneath the girl, right? Or the boy, depending on who's driving. Or on other factors. So then what happens is you get a little closer, and then the date either ends early or extends a little bit. Okay. Okay, so the question was, can you please talk about centrifugal, what was the other one you said? Centrifugal. This is the only real one here. Centripetal. Okay, so centripetal, and that means center seeking. It's like a Greek word, I think, and it means center seeking. So we're going to talk about centripetal acceleration in a little bit. And then if we have an acceleration, we're also going to have what causes acceleration? Force. So we're also going to talk about centripetal force too. Okay, but before that, let's look at a little bit more about this circular motion. Okay, so so we're talking about tangential speed or tangential velocity. So you can see right here it says when this tangential speed or velocity is constant, then we say that the motion is uniform circular motion. So those words right there are used on the AP test. Uniform circular motion, which means it's a constant speed, okay, for the circular motion. Now, if you look at my arm swinging, okay, so I want you to think about this with me here, people. So I've got a rope with a mass on the end of it, and this mass is swinging back and forth, okay? Back and forth. So my question to you is, okay, so later on in time, let's say that I've swept out, 1 rad in degrees. Do you know what a rad is? It's a radian, or how many rads are in one circle? Do you know that? 2 pi. Okay, so there's 2 pi rads. It's just a way of measuring angles. There are approximately 57.3 degrees per rad. Okay, so if I sweep out 1 rad, okay, here's my question. Does this angle measure, how does it relate to this angle measure? And this angle measure? How do those angle measures relate to one another? Right? They're exactly the same, right? Because it's only one angle, it's just I'm drawing it at different parts on this axis of rotation. Do you agree? So this would be called a constant angular motion. Okay, so the angle, the change of the angle is, well, I shouldn't say this is called constant. If I have something that's moving with a a uniform circular motion, it'll also have a constant change in angle or angular motion. Does that make sense? But now here's the question. If you were on a merry-go-round, okay, and you were going really, really fast in the merry-go-round, okay, would you feel a difference if you stood here, or here, or here, or here? And what difference would you feel, and why? Okay, so everybody knows that it's different. And we talked about, forces, and we talked about velocities and things. But now, so we have the constant change in angle, but depending on how far away we are from the center of rotation, then if you think about it, okay, let's just say that it takes 10 seconds to get around this circle. So it would take 10 seconds to go this distance. Okay, so let's just say that's 10 meters. Okay, so that'd be 1 meter per second. You agree? But if we, go out a little bit further, then, maybe that's, 20 meters, right? But you still do that in the same amount of seconds because this is all connected and there's no way to have a different swept out angle measurement. And then here, you might be, 30 and then 40 and so forth. So that's what happens with circular motion and how far away you get. So how would this be good? Well, if you were trying to place a satellite out in space that is over the same part of the Earth at all times, then you would have to match that, the satellite would have to match the angular velocity of the Earth. And it would have to be, close to the equator for it to work. And, who does that? Well, Sirius XM has 2 of them, I think, or at least 1. And those are called geostationary orbits, and they're approximately as far away from the Earth as the circumference of the Earth, approximately. And there's only so much out there. It's kind of like real estate. So who owns most of those geostationary orbits? Well, as of 5 years ago, when the stock market was falling, people were looking into Sirius Satellite. The government owned most of it, but Sirius has like 1. So it's kind of like a real estate spot. So if you're into like future real estate, you might think about buying up some space. Nothing. Okay. Anyway. So does that make sense? You may need to know that for the test. Okay, so let's see how this works. If we're constantly changing our velocity, then we know that we have an acceleration. So here's a new formula for you. Okay, because we know here is different than here, is different than here. And if you look at this, which direction would the acceleration be? Well, it looks like there's a pattern here, right? What does it always turn the velocity towards? Towards the center. So the actual direction of the acceleration, which you have to know this for sure, is towards the center. Okay, so then we're going to call that centripetal acceleration. And that you'll find that on your AP sheet, A sub C. And that is equal to the square of the tangential velocity and how far, or divided by how far it is from the circle, or from the center of rotation. So here's your new AP formula. Centripetal acceleration is v squared over r. Okay, so we saw some demonstrations and things like that. But what it comes down to then is we have acceleration centripetal, and that is completely 100% towards the center. At all points, the acceleration is towards the center. Okay, so if we have acceleration towards the center, what else do we have that's towards the center? Okay, force. So force centripetal is mass times acceleration centripetal. Now this is not going to be an equation on your AP sheet, but you absolutely have to be able to get it. It's just force equals mass times acceleration. So then you get force centripetal is mv squared over r. And that will be an equation that you need to use for this test and for the actual AP test. Okay, so let's look at just a couple examples here. This first one is talking about a car. That's pretty easy. Your acceleration centripetal is given at 8.05 meters per second. Okay, and the question is, what's the velocity? Well, that's just a plug and chug. You can do that plain and simple, no problem, right? But this next piece, you should probably look at a little bit more closely. Okay, so we're talking about a force centripetal. Now, if we're talking about a car on a road, what's going to cause that force centripetal? The rubber of the tires, right? That friction is going to cause that, because we need to have a force that keeps. So if we're moving something, we need to have a force that's centered towards, along the radius, along the circular path, okay? So, a car is pretty easy to do if it's on a flat level surface, right? And the force centripetal is going to be caused by the rubber of the tires, right? But let's look at something that's a little less straightforward. I'm going to explain this to you right here, but it's going to be explained in a little bit more space. Okay, so let's say that we have a tire swing. Okay, so tire swings, and they go round in a circle, right? You know what I'm talking about? So a tire swing on the playground. This is, you sit in the tire and you go round and round in a circle. Do you know what I'm talking about? People get sick on these when you get older. Okay, so where is the force centripetal? Well, it's going to be, now maybe I should draw this a little more dimensional. Let's say that my path looks more like this, because that's a little more dimensional. Do you agree? And that would be on a flat level. Okay, so let's look at this. This would be the tension. Do you agree? And the tension is caused by two different forces. What would those forces be? Well, gravity, right? So this is not gravity, but it's the opposite. That's what's causing the Y part of the tension. What would be the other part of the tension? Well, it would be the force centripetal that keeps it in the circular path. If there's no force centripetal, it's not going to be in the circular path. So we could say so let's say we have theta here. Could we say the force centripetal is equal to tangent theta mg? We could, right? Because opposite over adjacent, tangent theta mg. Or we could say the force centripetal is sine theta t. Do you agree? And this is a real common question that you're going to be asked to do some math with too. But anyway, that should clear a couple things up for you. Do you have any questions? Okay. Well, we'll stop there for today.